Hello, my name is Rebecca Bimrose, and I will be biomechanically analysing Rebecca's spike approach. The chosen sport for this assessment piece was volleyball, and the type of movement is spiking the ball, which is a type of attack from the game. More specifically, the spiker's footwork from their spike approach will be biomechanically analysed in order to identify problems throughout their movements. As you can see, the problem identified from the spiker's approach is her footwork. She continually takes off from one foot at the end of her approach rather than 2 feet. She also struggles with the timing of her spike approach. She is either too early and completely misses the ball, or she's too late. Newton's second law of motion states, the acceleration of a body is proportional to the force causing it, and it takes place in the direction the force acts. Force equals the product of acceleration and mass. Rebecca's mass is her body weight, and her acceleration relies on how fast she is moving. These two factors together determine the force or momentum acted upon her during her spike approach. Rebecca's momentum is transferred from horizontal to vertical during her spike approach, where her velocity and mass contribute to this factor. Newton's third law states, for every action there is an equal and opposite reaction. During Rebecca's preparation phase of spiking, the exerted force is placed against the ground, resulting in her body moving forward in a running motion. Once she is ready to take off, her feet are forced to push towards the ground in a downwards motion, forcing her body to react and take off. The action is pushing her feet in towards the ground, resulting in the reaction of taking off into the air. As you can see from the video, Rebecca has broken down her spike approach into 3 phases. The first phase being the transition outside of the court. Her second phase is the 2 steps towards the net, and the final stage shows her joining her feet together to take off. Her summation of forces consists of the sequence of these 3 phases. To produce the maximum force and speed, Rebecca's body movement should flow fluently from her ankles to the knees and finally towards the hips. For Rebecca to gain optimal force and speed, her timing must be correct. As you can see from the video, Rebecca continually takes off from only 1 foot instead of 2. You can also see she is very early in her spike approach, and as she jumps she misses the ball completely. Levers are a bar or some other rigid structure hinged at one point and to which force are applied at 2 other points. The preparation phase falls under the second class lever because it utilizes the force component. Rebecca's fulcrum is situated within her ankle levers through dorsiflexion and plantar flexion from the spike approach. The motive force acts to rotate her lever directing Rebecca towards the ball, whereas the resistive force acts to resist the rotation of this lever through gravity. Next, we are going to talk to Rebecca about goal setting.
What are your goals for this constraints-led approach lesson?
I want to be able to take off with 2 feet to enhance my height jump and balance as well when hitting the ball, as well as having a good transition to the spike approach.
The problem consistent through Rebecca's spike approach involved her takeoff and timing when spiking the ball. Rebecca's takeoff problem occurred during her final stage of her spike approach. She's continued to jump off 1 foot rather than 2. The other problem occurred with her timing when approaching the ball. She usually found herself to be too early and the ball would fly over her head. By implementing constraints for Rebecca's spike approach, improved the issues of takeoff and timing. The first constraint introduced for Rebecca's spike approach was a task constraint. The ball was thrown over and tight to the net and her only instruction was to hit the ball. Rebecca was already standing on the net, so her only option was to jump and spike the ball. The task constraint forced Rebecca to take off from 2 feet rather than only 1 foot. Rebecca was then allowed a run-up before spiking the ball. As you can see from the previous repetition of jumping on the spot to spike the ball, she takes off from 2 feet automatically.
How did you feel hitting the ball in a standstill position?
I think it was good. good because I got to focus on just my footwork without having all of the arm movements and everything else to worry about, as well as my runner.
Do you feel like it helped improve?
Yeah, because I think that once I transferred it into my spike approach, I was thinking more about my 2 feet, and I knew how to hit the ball using just from jumping off my 2 feet, as well as now implementing it in the spike approach.
What do you think the difference between jumping off 1 foot and 2 feet? What is the difference between the two?
So 1 foot, I felt unbalanced all the time every time I hit it, as well as when I hit off with 2 feet, I get a higher jump as well, so therefore I'm higher on the net, so I can produce it over the net and stronger spike too.
The next constraint implemented was also a task constraint. Rebecca had to transition around the marker and say "now" when the ball was at its peak to initiate her spike approach. This allowed for the appropriate timing to occur. This task constraint improved Rebecca's timing on when to start her first phase of spiking.
What do you think the purpose of the marker was?
To help transition from into my spike approach, therefore I was outside the court ready to hit the ball, and that way I had more options when hitting the ball, as I could either hit, as I was coming in on diagonal, I could hit cross court or down the line.
What was the purpose of saying "now" before you start your spike approach?
When I said "now," the ball was at its peak, therefore I knew when to start the spike approach, and I could organise my timing accordingly. The chosen sport task is the volleyball spike, but more specifically, just the arm swing stroke process. Throughout this section of the video, the biomechanical principles that underpin this particular movement will be defined and explored in depth. To build upon that, from a video recording of Rebecca, her strengths and weaknesses of the particular skill will be identified using the background knowledge of biomechanics. Constraints will be added to help improve those weaknesses and make the volleyball spike more efficient and powerful. Throughout all this, Rebecca will use her goals for what she hopes to achieve by the end of the training. This will improve her learning experience. To describe the movement, I will be focusing on the arm swing stroke process of a volleyball spike when the human body is in flight. The problem that I have identified in Rebecca's movement is that she is not rotating her trunk when spiking the ball, therefore 9 times out of 10 hitting cross court. A study was conducted mentions that when there is an interruption in the forward trunk rotation just before impact, there was a result in a decrease in the swing velocity of the arm. Rebecca is not rotating her trunk at all, therefore losing a great amount of velocity that could be impacting the ball if the skill was executed correctly. Not only is she losing speed and force in her spike because her body is not rotating correctly, she also ends up in the net at the end of her shot, thus leaving her unbalanced and unprepared for a blocked shot. The arm swing stroke phase can be broken down into 3 sections: backswing, turn swing, and forward swing. In most, focus will be the turn swing, but all components of the spike are crucial to optimal success. Through the backswing phase, this is where Rebecca will begin her movement. This is a leading back swing at the beginning of the takeoff and a pulling back, which is initiated by the pull of the elbow and wrist simultaneously. From Rebecca's movement, you can see that she has clearly pulled back her elbow ready for her spike approach while leading up to the net. This then leads to the turn swing phase, which is the most important for this analysis. The turning of the trunk occurs, which allows for a greater range of motion. From this, the arm will naturally go into an upside down V position prior to the swing phase. It is clear that Rebecca makes an upside down V position with her arm while doing the turn swing phase. This is crucial for the rest of the swing. Lastly, during the swing phase of the arm stroke, the elbow straightens up until the ball is hit by the extended hand, which is slightly in front of the shoulder for the optimal range of motion and forward momentum is struck. The athlete in this movement pattern is using Newton's third law of motion, action and reaction force, as well as the conservation of angular momentum to transfer power to the ball.
Man 2008. Rebecca has evidently put her arm as high as she can when hitting the ball. Her extended hand is almost completely straight except for a slight bend in the elbow. Newton's first law of inertia is simply defined in volleyball. When the ball is set for the spiker, it will travel up and fall down due to the force of gravity. Therefore, the ball will stay in that current state until a force is acted upon it, that being the spiker's hand. Once again, simply put, Newton's second law of acceleration. The faster the arms swing, the greater the force that will be exerted onto the spiked volleyball at the moment of contact. In line with Newton's third law, Rebecca needs to make her waist, abdomen, and lower limbs generate enough force at the same time to make an opposite movement with the upper limbs. The larger the moment of momentum generated under rotation of axis, the larger the opposite momentum generated by the upper limbs to have a successful forceful stroke. The lower body should be creating an anti-radian in the lead up to the spike. At the moment of contact, the body creates a radian, like the picture from before, from the upper limbs and lower limbs rotating around the axis quickly. Thus, the upper limb will generate maximum momentum and therefore achieve a more forceful spike. You can see that Rebecca has demonstrated both of these movements. A volleyball spike is used when creating maximum speed and power through a shot. This relates closely to a third-class lever. The force that is applied, effort, is between the resistance, weight, and the fulcrum pivot point. A third-class lever allows the body to move a short distance, for example, the wrist movement, but the arm, which acts as the end of the lever, moves a much greater distance around the body. Long arms allow for increased angular velocity and the ability for an object to rotate around an axis. The greater the distance between the axis of rotation, that being the elbow joint, and point of contact, the higher rate of velocity Rebecca can achieve. As you can see, Rebecca has achieved an almost perfectly straight arm. Rebecca has many strengths and weaknesses. The weaknesses including a lot of cross-court spiking, therefore there is less down-the-line spiking, which results in less shot options. This is because there is not enough trunk twist when spiking the ball, and it also leads to an unbalanced landing in the net. Her strengths include generating powerful shots, a great jump height, very high levers, and a great spiking pattern knowledge.
Okay, so what do you want to achieve from this?
I want to be able to hit down the line more, as I can only hit cross court.
Yeah, why do you want to hit more down the line?
Because it's a harder ball to defend.
Yep. How can you measure hitting down the line more?
Well, I can count the balls, like depending on how many balls I receive, I can try and hit at least half of them down the line and then half cross court.
In an attempt to correct Rebecca's weaknesses, a constraint will be put in place relative to the skill, breaking the opposite side of the court to have different scoring elements. The court will be split into two different sections. The first and prioritized section is hitting down the line. There are markers set out this section of the court. This is to encourage Rebecca to aim to be awarded 3 points if she can hit within this section. The rest of the court is only worth 1 point, as any shot is still valuable in the game of volleyball, but the main focus is down the line. As an internally focused constraint, there is no explicit instruction on how to hit the ball, instead a targeted and marked out area. From watching the video, it is evident that Rebecca has used the constraint to her advantage by ticking off her goal by hitting at least 5 shots down the line, 4 cross court, and 1 down the middle, which is evidence of her adjusting her shots. Her shots also show more stability by hitting down the line instead of cross court. To progress the constraint, a chair was placed in the ideal area of a defender, which was in the zone worth 3 points. This then gave Rebecca a new target and focus point. As she clearly managed to rotate her shoulders and hit down the line, her goal is now to either spike down in front of the chair or up and over the chair. This constraint is about using the chair to act like a defender, to be aware of surroundings, and self-organize to make decisions on how to hit the ball.
So, having the chair down the line, like demonstrated behind you, in a defender's position, what do you think that will do to your hitting?
Well, having a defender there, you obviously don't want to hit it straight to the defender. So you either hit it behind the defender, or you can drop it short or to the side, more inside the court.
Do you think having the defender there helped when you were hitting?
Yeah, I did. It had a bit of Like, made me think about positioning or placement of the ball, where to actually hit the ball, because you don't want to get into the tackle.
Here comes the, y'all don't really want it like that. Yeah. Here comes the, y'all don't really want it like that. Yeah. Here comes the, y'all don't really want it like that. I said so, I keep big bills up in my heart on the dirty like blood.
This is Dylan. Dylan has started playing in weekly social competition and uses an underarm serve to start a point. He has said that he wants to be more competitive and do an overarm serve to create pressure on his opposition. As the overarm serve is a new skill to him, he is at the cognitive stage of learning and assembling a coordination pattern phase of Newell's triadic formula in terms of skill acquisition. An overarm serve is classified as a serial motor skill because it involves a series of discrete skills linked together in a movement sequence. Throughout this video, we will explore the biomechanics and kinematic theories relating to serving and help Dylan become a consistent performer. Serving is explained by Newton's first law of motion, inertia. An object will remain at rest until an external force is acted upon it, meaning when the ball is tossed, it will simply go up and down until you apply horizontal force in a general motion to change its velocity and trajectory to make it travel forward. When you make contact with the ball, it is known as the moment of inertia. The amount of inertia is dependent on the mass of the object. A volleyball has a larger mass than a balloon, so its inertia would be greater, but less than that of a basketball, for example. Performing an overarm serve uses a third-class lever to create torque. The elbow acts as the fulcrum or axis, the ball is known as the load, and the force comes from the forearm and wrist. A third-class lever creates advantage in speed and range of movement. The muscles in Dylan's hitting arm must be stretched to optimal length. This is called optimum stretch. Positions of optimum stretch will enable him to contract the muscles with maximum force, i.e., the longer the lever, the larger the force. Dylan is not contacting the ball at his optimum stretch, and so is not generating the desired amount of force. The trajectory and flight path of a volleyball is directly affected by pressure differentials as expressed by Bernoulli's principle and the Magnus effect. The Magnus effect is when the spin of the ball generates displacement of forces and pressure differentials on the ball. There is faster air on the top of the ball, which is less pressure, and slower air moving under the ball, which exerts more pressure on the ball. This, along with external forces such as gravity, is what causes the ball to drop. If force is applied on either side of the ball's center of gravity, which is called eccentric torque, the object will rotate, creating spin. The angle of release of the ball determines the time the object stays in the air and the horizontal distance it travels. The flight path of a volleyball is almost the shape of a parabola, however, air resistance can affect it. The height of release is also important in terms of trajectory. The higher the height of release, the greater the horizontal distance it will travel. As his optimum stretch causes his height of release to be roughly 2.15 meters, Dylan's optimal angle of release is 42 degrees to allow for maximal horizontal distance before gravity acts upon it to make the ball drop. At the moment, Dylan is not reaching his optimum stretch, so his height of release is too low and his angle of release is inconsistent. This is why the ball is not traveling over the net. As well as our physical ability to complete a motor program, performing a skill requires a good level of concentration. Concentration is when you are directing and maintaining your focus of attention on the right things at the right time. A common internal distractor that impedes concentration is worrying about past results. You can see before each serving attempt, Dylan performs a routine. Routines have shown to be effective tools to allow performers to mentally prepare and concentrate on the actions that they can control and that are relevant to successful completion of the skill. Using recognition schema, Dylan can evaluate his last executed movement based on outcomes, sensory information, and environmental conditions. Performance relies heavily on the athlete's mental state in terms of anxiety and arousal. To perform at the optimal level, there needs to be a correlation between Dylan's arousal and anxiety levels. This can be explained using the inverted U hypothesis. If his arousal and anxiety levels are too high, his attentional field is narrowed, and this decreases his environmental scanning, meaning that he is more likely to rush into the skill and make unforced errors. If his anxiety and arousal levels are too low, however, his attentional field is broadened, and he is focusing on inappropriate cues, which would also cause unforced errors. After a quick analysis of Dylan's serve, he was asked to fill in a goal-setting table to specifically identify his goals and how he may achieve them. He identified that in order to reach his target skill of an overarm serve, he needed to have a high contact point or moment of inertia. He was told to use CARS goals, meaning it is challenging, attainable, realistic, and specific. This will help increase Dylan's motivation to improve and achieve his desired performance level. For this task constraint, a rope has been attached to the top of the net and stretched out to attach to the referee's stand behind the baseline. The rope acts as an invariant feature. The task is for Dylan to serve the ball so that it is contacted above the rope. It then has to travel above the height of the rope until it reaches the net, when it can drop below it. Rather than giving explicit technical feedback after each attempt, Dylan receives augmented feedback through knowledge of results. This constraint is based on a closed-loop feedback system, meaning that memory containing the intended movement is compared to the desired outcome and the performer adjusts until they exert the ideal performance. As expected, Dylan first struggles to achieve the desired performance outcome, but after repetitive practice, he becomes successful and the constraint begins to decay. The constraint was then reconfigured by changing the parameters. Dylan was pushed further away from the net. Standing further back causes Dylan to self-organize his performance schema after viewing the affordances provided to him to allow for the ball to travel the extra distance. As the conditions are different due to the increased distance, a period of regression was experienced. Dylan was able to serve the ball over the net at the shorter distance, but at first struggled to do so when on the baseline. As Dylan became more attuned to the affordances given to him and his motor program developed, the constraint decayed. The emergent behavior exerted is that he can successfully contact the ball at the correct height and angle for the ball to travel over the net. These two constraints were designed without any external distractors present to detract Dylan's attention and concentration away from the task at hand. Looking back at Dylan's goals, he has successfully reached his desired outcome. Dylan is in a state of degeneracy, meaning that he is capable of using distinct parts of complex neurobiological systems to achieve similar performance outcomes in varying contexts. Now that he is more successful in the skill of overarm serving, Dylan's self-confidence has increased because he has met his goals and believes that he can perform at his ideal level. Dylan is working towards skill mastery, which is the ability to perform a task with minimum exertion but maximum accuracy.